Hello, welcome back guys. Today we'll understand what do we really mean by the term differentiation. First of all, let's say y equals to fx and we need to find the slope of this tangent drawn at the point A. That's a very hard task to do. Not really, but with initials it's a little hard. So why not try with a simple case? Let's say we have a secant here and we have the point A plus h, and the secant passes through these 2 points on the graph. So for clarity, let's write it secant. Now this secant has a point on it here and a point on it here. So it's a line with 2 known points. So can we find the slope of this secant? Actually yes. So we write that slope of this secant is given already by changing y by changing x, because we know that for slope we need to find the increment vertically by the increment horizontally. That is change in y by change in x. This is change in y and this is the change in x. Change in y is the difference between these two. That is f of a plus h minus f of a by the increment here, that is h. Many of you will ask how this point is f of a plus h and how this is f of a. Now you see we have this graph. At a point A we have a value that is called by f of a, and at point A plus h we have the value that is called f of a plus h. And so this length del y will be the difference between these two lengths, that is f of a plus h minus f of a, and the del x is the difference here, that's this length, that is h, difference between a plus h and a. So we have easily found the slope of this secant. Now we need to understand the tangent is nothing but this secant when this point comes closer to A. Let's say this was point A and this was point B, and say that B has come closer till here and it's called B dash. Now if we draw, the secant may look like this. So I arrange the drawing. Let me make it clear. The secant will look like just this as the point B comes closer. So this secant and this tangent are superimposing each other as the point B is coming closer and closer to A. If the point B was here, the tangent would like this. If B was here, the tangent is like this. If B is closer, it is approaching the tangent. The better word for this kind of situation is approaching. So limit as B tending to A, that can be written also as limit this point is coming closer so that B will come close. So limit A plus h is going to A. Now see, as A plus h tends to A plus h minus a will tend to A minus a, because you have subtracted the same. This will come h approaches to 0, that is equals to limit these two are equal h approaching to 0. The slope of this secant, all we are doing is with the secant only. We get slope of this tangent. So to find the slope of the tangent, that was initially a very hard task for us. We get it as slope of tangent equals to limit as h tending to 0, the slope of secant that is initially calculated to be f of a plus h minus f of a by h, and this slope of tangent is known as the slope of the curve at point A, or the slope of the curve is represented by f dash of a. This means that if we draw a tangent at the point A, what will be its slope? And its slope is represented as f dash of a, and we have calculated it to be this limit h tending to 0, f of a plus h minus f of a. Sorry for bad diagrams, I am not having so much good drawing capabilities or drawing skills. Now we have an expression for f dash of a and we are calling it the derivative. So we can now safely infer that derivative is nothing but the slope of the tangent at the point A.